So you have the quadratic pattern. We're on page 3 of your booklet. We're first going to just focus on the table, then we'll write, and then we can go back and look at the prompts in your book. But let's first get you guys on the table part, okay? So we're going to fill out the chart by what we have, correct? And so for the first term, you have 1 square, right? For the second term, you have 3 boxes or 3 squares. Yeah? Third one, 3, 4, 5, 6. How many are 4? 10. Okay, so if we wanted to draw 5, how many would 5 have? 15. Okay, now how is it growing? So see how term 1, there's only 1 box at the base. 2, on term 2, see how there's 2 boxes on the base. Third one, there's 3 squares or 3 boxes at your base. 4, there's 1, 2, 3, 4. So we know 5 would be 1, 2, 3, 4. Okay, well, they're not perfect squares. And then you would just decrease going up and decrease going up. So 5, 4, 3, 2, 1, and so that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Correct, right? So they asked us to draw, right? So on that page 3, assuming the pattern continues, draw the next figure in the sequence. We have that there, right? We'll do the figure 10 later on for this. But we're going to just kind of stick to here. Okay, keep going. All right, now you guys, okay, what's your first difference? So add, subtract, multiply. All right, it's a quadratic pattern. So look, to go from 1 to 3, how much would it increase by? 2. And what about 3 to 6? 3. And what about 6 to 10? 4. 10 to 15? 5. Okay, so we're assuming as we move along, this would be what? 6, and this would be 7, and this would be 8. Right, okay, so if you have enough of them, you should see the pattern that the first difference is not a constant increase or decrease. It is an increasing increase by 1 unit, right? And that's where the second difference comes into play. So a quadratic sequence or a quadratic pattern is not going to have a consistent first difference. They're going to be different. There's a pattern to them, but they're different, okay? So if it fails the first difference and now you're moving on to the second difference, that's why it's a quadratic sequence or pattern. Okay, so now we go to the second difference. And now from 2 to 3, it's a +1. From 3 to 4, it's a +1. 4 to 5 is a +1. 5 to 6 is a +1. 6 to 7 is a +1. And 7, 8 is a +1. So that is your, I'm recording. That is your consistent growth, okay? That tells you it is a quadratic, it is a quadratic pattern. Now, had this failed, 1, either you guessed incorrectly, so you, okay, so if both of these are not consistent, then either you did something wrong, go back and see, because obviously we're going to give you patterns that are neither, right? But chances are, if it's a quadratic, you guys are leaning that way, and you guys don't really have a problem finding the neithers. It's just the quadratic, so you guys don't go into the extra credits, some of you, okay? But you guys are great with the table. Fair enough? Yeah? Okay. Okay, so this is your second difference. So here then, it tells you for question 2, how many blocks will be in figure 10. So let's just find that one. So 15 plus 6 is 21, right? 21 plus 7 is 28, right? 28 plus 8, 36. This is 9, 45, 10, 55. Okay, so it said how many blocks will be in figure 10? It would be 55 squares. Not bad, right? Okay, so here, you guys are done. This is your mandatory part of the quadratic pattern. You have to show me the first difference, you have to show me the second difference, you have to show that there's a consistency with the second difference. That's it. And now I'll stop the video, and then we'll go into another video where now, that one's the longer one. We have to now do the algebraic recursive explicit equation writing. All right, let me just pause it so it doesn't keep going.